Students, you might already know that bricks are the building blocks of a construction. A building is made up of bricks, concrete, cement, etc. You also might have noticed the breaking of bricks with a hammer by the workers as their requirement. What if we try to break the pieces with more hits? It will become smaller and smaller, right? If we continue this, finally we'll get dusts of soil, won't it? Do you think that these dusts are the smallest possible form of the soil? Can we break these dust particles into the smallest units? Yes, but not with a hammer. By using lab techniques, we can break them into the smallest unit, and that smallest unit of a matter is called the atom. Would you be able to visualize how tiny an atom is? We can't see it through naked eyes, not even through normal microscopes. Only special electron microscopes can be used to see it. The atoms are so small that their radius is measured in nanometer scale. Do you know how small 1 nanometer is? 1 meter is equal to 10 to the power 9 nanometer. This tiny atom has the same property as the material. The atom of soil will reflect the property of bricks. Similarly, the atom of iron will reflect the properties of a knife. The entire world is made up of atoms. Atoms are the building blocks of all the living and non-living organisms. Like materials, atoms also have physical properties like mass and volume. The mass of an atom is termed as an atomic mass. Atom, the building block of all matter, was considered as the indivisible unit as proposed by Dalton. After the concept of atoms had been widely accepted, the hunt for digging deeper inside the atoms came to the mind of science enthusiasts and other philosophers. A universal question came to everyone's mind. Around the end of the 19th century, all the science community was trying hard to find out the answers. Are atoms really indivisible? What's inside an atom? The science community found a new lead during the hunt for the nature of atoms. They observed the amazing behavior of static electricity conducted by different substances. You may be astonished to hear the term static electricity. Let's do an activity to understand static electricity. Take the dry and well-cleaned comb you have in your home. Make sure it's not either oily or greasy. Now comb your dry hair with the comb. Now bring the comb near to some piece of papers. It's really cool, right? Similar attraction behaviors we can also observe between glass rod and balloon, and wooden cloth and body hairs. Rubbing two objects together makes them electrically charged, due to which they show the behavior of attracting other things. Since the atoms of the matter get charged, that means the atoms are not indivisible as said by Dalton. They must consist of one or some charged subatomic particles. This led to the discovery of subatomic particle electron and protons, which was identified by J.J. Thomson and E. Goldstein respectively. Discovery of proton. The presence of positively charged particles in an atom had been first observed in 1886 by E. Goldstein, based on the concept that atoms are electrically neutral, that is, it has the same number of positive and negative charges. He performed a series of experiments and observed that when high voltage electricity passed through a cathode tube fitted with a perforated cathode pierced disc containing gas at low pressure, a new type of ray was produced from the positive electrode anode which moves towards the cathode. These new rays he termed as canal rays, positive rays or anode rays. And the positively charged particles are named as protons. Discovery of electrons. In the late 19th century, physicist J.J. Thomson began experimenting with cathode ray tubes. Cathode ray tubes are sealed glass tubes from which most of the air has been evacuated. A high voltage is applied across two electrodes at one end of the tube, which causes a beam of particles to flow from the cathode, the negatively charged electrode, to the anode, the positively charged electrode. The tubes are called cathode ray tubes because the particle beam or cathode ray originates at the cathode. The ray can be detected by painting a material known as phosphors onto the far end of the tube beyond the anode. The phosphors spark or emit light when impacted by the cathode ray. To test the properties of the particles, Thomson placed two oppositely charged electric plates around the cathode ray. The cathode ray was deflected away from the negatively charged electric plate and towards the positively charged plate. This indicated that the cathode ray was composed of negatively charged particles, and the negatively charged particles are termed as electrons. This is how the discovery of electron and proton was made.